Okay, so today we're going to talk about polynomials and specifically end behavior of polynomials and how we can kind of predict what these things will look like just looking at the equation. So let's define what a polynomial is first. So it's an expression of more than two terms. So remember, terms we separate by, like, an x is a different term than an x squared is different than a constant, just a number term. So a couple of rules also. You can't divide by a variable, which means no negative exponents either, right? Because negative exponents are the same as moving that exponent to the denominator, which would make it a division. So no negative exponents. And then also no decimal exponents. So they need to be whole numbers, whole positive numbers. So, and more than two terms. So a binomial would be two terms. A polynomial is more than two. Okay, so if we think about an example of something we know to be a polynomial, we can think about a quadratic. So that could be an x squared plus x plus some constant. That would be a polynomial. And what we're going to talk about today, what we're going to look at is polynomials of greater degrees than 2. And what you're going to see starts to happen is we get hills and valleys and hills, and then you get something that looks like that. So that is also a polynomial. So two different expressions that are polynomials, you could have something like 3x squared plus, or cubed, plus 2x squared plus x minus 2. That's a polynomial. Notice we have 4 different terms there. You could have x to the 5th plus 2x to the 3rd minus 2x to the 4th plus 6x to the 6th minus 5. And notice in this first example here, this is in descending order. We started with the greatest exponent value of 3, went to 2, then this is a 1 right here, and then no variable at all. So that's in descending order. This one is not in descending order. If we wanted to order these in descending order, this would be my first term because it has a degree of 6. This would be my second term, degree of 5. This would be my third term, degree of 4, and that would be negative 2x. Remember that the operation goes with the guy behind it. Then we'd have in fourth place, we'd have our degree 3 term. And then last but not least, we would have our constant as our 5th term over here. Again, we don't have a square term or a just a variable, so we jump right to the constant at the end, but ordered from least to greatest if we were putting that in descending order, and that'll matter later. So two expressions that would not be polynomials, you could have something like 2 divided by x. That's not a polynomial because we have a variable in the denominator. And then you could have something like 3x squared plus 5x squared plus 7x squared. Now, technically, you have 3 separate terms there, but when you add them together, if you were to simplify that, that's really only one common like terms. So that does not count as a polynomial. That is actually a monomial when you simplify it. Okay, so why did I talk about this descending order business? Because we're going to look at the highest degree test. We're going to look at the exponent that has the highest value. So ordering these from least to or from greatest to least is helpful in that regard. So in this case, we have a degree 6 term. So if the degree is even, notice 6 is an even number. If the degree, which is again the highest exponent value, if it's even, then the arms of the polynomial will face the same direction. Face same direction. So notice on our quadratic, we had arms both facing up. So that's an even degree polynomial. Now, if you have a degree of 6, that means you're going to have a lot more hill and valley action before you end with the arms up. So you have something more like this. And now when we talk about what the degree is, that also corresponds to the maximum number of roots, the maximum number of times this thing could cross the x-axis. So notice if I were to draw my little pretend x-axis there, this guy crosses twice. This is something like x squared plus whatever, whatever, whatever. That's a square term. It could cross twice. Something like this, if I were to cross the maximum number of times, that would be 1, 2, 3, 4, 5, 6. So this is x to the 6, something, something, something. Again, the maximum number of times it could cross the x-axis if all the hills and valleys were to make sure that it crossed the maximum number of times. Okay, so then if we have an odd degree, like we do here, we have the highest degree is 3. We check this is in descending order, 3, 2, no 1, just a constant. So that is an odd degree. Then the arms of the polynomial will face opposite directions. So we've talked about linear functions. That's a degree 1. That's just x plus some number, right? So y equals mx plus b. That's a linear function. So that's an odd function. Notice this arm is going down. This one's going up. We talked about cubic functions. Something like, that actually is not a cubic function. Let me fix that there. If we go like this, that's a cubic function. And that is... so x to the power of 3. So if that were to cross the maximum number of times, the first way I drew it to sort of illustrate that, you would go across 1, 2, potentially 3 times. Again, that's a x to the power of 3. So cubic function. If you then had to the power of 5, it would cross a maximum number of 5 times. Boop. So if you were to draw your imaginary x-axis, 1, 2, 3, 4, 5 potential x-intercepts, 5 potential roots. We'll talk about that again next week, so don't worry too much about that now. Let's focus on odd and even degrees and what that means for arms. And then we're also going to talk about what the leading coefficient does to the arms. So in this case, we have a negative leading coefficient. So that means that think about what a negative a value does in a quadratic. So that makes the arms face down, right? So we're going to change the directions the arms face. So if we have a negative leading coefficient, then the right arm of the polynomial will face down. Or you could also say go toward negative infinity, because the y values are going to fall to negative infinity. So if you have an even function, like this one is, to the power of 6, then you have something like this, and the arms are going to face down. In this case, both arms will face down because this is an even degree, but the key here is the rightmost arm is going to face down because it's negative. So if the leading coefficient is positive, then the right arm of the polynomial will face up, or it's going to go toward positive infinity. So this is really y going toward positive infinity or y going toward negative infinity, again, how we describe end behavior. So an example of that with an odd degree, you would have something like that, ending on a high note. So this rightmost value, when we look at that arrow, is going up toward positive infinity. If you have an even function, then both arms are going to face up. So an odd function, just the right arm will face up. An even function, both will. Over here, an example of an odd function that is a negative leading coefficient would look like that. So you'd start high, but you'd end low over here going toward negative infinity. And that's what we're focusing on for this week. So I'm going to do one more example for you that's like your practice set for this week, and look at what we're asked to do there, and then we'll call it good. So actually, I'll do that on a different video and post it for you as optional. Okay, hope you guys are doing well. Miss you all so much.